Thanks for the introduction, Rob. So don't really have to do much introduction of myself here. I'm teaching the Sec 522, the web application security, as well as ever so often Dave Holzer's class here, the intrusion detection class. And really great always to see Dave talk about what new uses and such he has of his machine learning skills here that he sort of acquired. The talk I'm going to present today is actually a little bit unusual for me. It's less technical, this talk. It's really more talking about ethics and how to use some of these new tools that we now have, in particular when it comes to information security research. And this talk is also motivated and, well, inspired, I should say, by the work I'm doing for SANS.edu for our college, where, well, I'm sort of leading as Dean of Research, the research efforts that our students sort of put in place here as they're writing their papers as part of their master's degree. If you ever go to the SANS website, we have like this reading room, or SANS.edu, the cybersecurity research section, where you can find some of the papers they're producing. And I can only say we have a bunch of machine learning related papers, AI related papers sort of in the pipeline. So you'll see more of that. But what is really necessitated is thinking a little bit what guardrails we need to put around how our students are using AI, are using machine learning. And I'm following a little bit Rob's lead here, that I kind of use the two terms interchangeably as far as this talk is concerned. Yeah, currently I'm living in Jacksonville, Florida, grew up originally in Germany. And well, when we're talking about AI, so why are our students so interested in AI? Well, as Dave put it, it comes up in consulting engagement, it comes up in your job. If you're trying to look for a job right now, and you're telling a company, I want to do the best job possible protecting all your customer data, they say, go away, we already lost that. But what we really need is, we need someone to protect our machine learning that we invested so much money into. We bought all these GPUs, we hired all these data scientists. And so doing some information security research around machine learning AI is really critical at this point. What I want to talk about here is, again, this is sort of informed by what we're doing here for SANS.edu. So I'll start a little bit with sort of that thing that actually first came up is cheating and detecting use of AI. And then later, in the later half, to talk a little bit more about how do you actually use AI, and how do you do research, and how do you do that correctly and responsibly. So, but anyway, let's talk with the cheating part, plagiarism. The problem really comes down to a very simple question. If you're using AI as part of a term paper, any kind of work product that you're submitting, how much of that product is your intellectual property? How much did you contribute to this product? If the overall idea and such is yours, you just used AI, ChatGPT, Grammarly, some of these tools to help you put the words together in a nicer way, then definitely use of AI is fine. It's okay. It's encouraged. We want students to produce readable documents. We just want these readable documents to contain actual ideas that they had that are original to the student. But so what does it mean if you're using, let's say, ChatGPT? Now that's the number one tool that people like to use these days. Remember what ChatGPT is. It's a natural language interface. It's already came up a couple times. Think of ChatGPT as a more user-friendly version of Google or Wikipedia. So as far as academic research goes, if you're putting a prompt into ChatGPT, you have to find the original source where OpenAI, when it did spider the web to train its model, where it actually found this. And ChatGPT can help you with this. It can help you find that original source. So, for example, I did a little experiment here just to show this off. Yeah? Again, my 503 background is showing a little bit here. What TCP offset is the protocol field. And I, in particular here, try to sort of trick it a little bit. I didn't say IP header, I said TCP header, not just to see, hey, what does it come up with? Yeah. Well, it actually calls me out on this. It's that TCP header, there isn't a protocol field, and then it talks about IPv4 and IPv6 and where to find the protocol field in those headers. So, great save here from ChatGPT, something that may have had a harder time with Google, for example, if you ask it a perfectly wrong question like this. But then the next step that you should always include is, hey, what's your source? What's your source of that information? And here, ChatGPT again does a great job. It points to the RFCs, which are the authoritative source for all information sort of IP/TCP related. So if you're writing a research paper mentioning this as a source, great, that works. I believe you can even make it formatted correctly for APA or whatever the formatting requirement is that you have for your particular paper. However, this can go wrong. Remember those hallucinations that ChatGPT is sometimes known for? There's some famous cases. There's, for example, a lawyer used it like this. And the case references that ChatGPT came up with, well, it didn't exist. So always double check your result. Just like when you used Google, just like when you used Wikipedia. Wikipedia, it's a great reference. It's a great way to quickly find the original source. Actually, Wikipedia is almost easier because it's pretty good about listing the original sources as part of the Wikipedia page. But you all know that Wikipedia sometimes goes wrong. Yeah, trust but verify, Tyler says here. That's definitely what you would like to, that's the rule you have to apply for. So anyway, this is just a cheating part. It's okay, in my opinion, and that's sort of our policy at Stanford EDU, to use tools like ChatGPT, declare how you use them. In the end, you are responsible for the result, and you have to find the original source. So you can't just say, hey, ChatGPT ate my homework. That does not really apply. But anyway, so instead of getting to the end of the program, you want to write a research paper. How do you use AI as part of your research papers? And these are sort of some of the ways that I've seen people use it. First of all, you can use an existing AI model online. There are a couple of great resources that allow you to download the code for trained AI models, Hugging Face, TensorFlow Hub. So that's another way. Then you run it on your own hardware. That may, for example, be more appropriate if you don't want to send your data out to some cloud service like ChatGPT or whatever. And then, of course, the probably best way to do information security research in some ways is, well, create your own model. But of course, it's difficult. It has always some dangers associated with it. And then the question also becomes, do I really need an AI model, or what do I actually need? Yeah, and David is saying, Wikipedia is a big no-no because it's not the original source. So you can use Wikipedia to find the original source, but not the Wikipedia article itself. And that's similar with ChatGPT. ChatGPT may be able to direct you to the original peer-reviewed resource. It's not the source itself. So using existing AI models, probably one of the best uses I find of these AI machine learning models is something like GitHub Copilot. A lot of the times, doing information security research involves writing code. You may have an idea for a particular algorithm and such, how to use it, but your Python or whatever language you're using is a bit rusty. So as a result, you're using something like GitHub Copilot. And again, it comes down to, well, if you're using it as a tool to aid you in coding, nothing wrong with this. You're still responsible to make sure that the code is correct. I always compare it, my education originally was in physics. If you're doing research in physics, you're often using equipment like X-ray sources, you're using detectors, you're using accelerators. You're not going to build, usually, unless that's the focus of your research, the X-ray source. You're going to buy one. You may have even some technician who will help you set it up. because that's not actually sort of the core of your research question. If your research question is, hey, how can I get a better, greater, brighter X-ray source? Well, then maybe you're going to build it yourself. Maybe then you're going to understand the ins and outs on how the power supply for it works and how the focusing system works. But usually that's not necessary. Similar here, if you're creating, we had actually just a student that was creating some tools to collect information from ICS devices. So to do some inventory and configuration checks on ICS devices. Well, that student used Copilot to write some of the code and worked beautifully, worked great. But of course, that student was still responsible that the code actually worked correctly. Actually, a piece of code I have here looks syntactically correct and such, but doesn't do anything useful. The way I wrote this is I basically just gave Copilot the comment and it filled in this particular piece of code and it used some of the code that sort of was already in the script. So it wasn't completely off, but in this case, didn't really do anything particular useful or not really sort of what I wanted it to do. Now, when you're using a tool like Copilot is who owns the code? You didn't write the code, Copilot wrote the code. Well, luckily, GitHub is pretty explicit here that you own the code. It even indemnifies you if you're a paying customer. And the problem here is, again, a little bit like the problem that OpenAI had, and a lot of these models have these days is what training data did they use? Tools like Copilot often, they basically just enumerated and parsed open source code they found around there, but there are tons of different open source licenses out there. Not all of that code they were necessarily authorized to use to train a machine learning model. GitHub Copilot actually has a special switch that you can enable and that you should enable that will tell it, hey, don't create code that's verbatim already out there. So don't just copy paste code from existing repositories. And I did some experiments there, and sometimes you actually end up with verbatim code that you find, for example, on Stack Overflow. And then, of course, it gets a little bit more iffy as to who owns the copyright of this code. But what this comes down to is when you're thinking about using one of these models, whether it's ChatGPT, whether it's Copilot and such, the prompt in some ways becomes the intellectual property. So that's really where your contribution lies in creating the correct prompt, in getting a useful, valid response back. Now, there's of course some research even around creating prompts. The entire games with prompt injections, bypassing some of the constraints and such, maybe finding a better, more valid, a more correct answer than you originally got with the prompt, and coming up with ways to sort of write better prompts. That's a legitimate sort of area of research at this point. The next thing, of course, you can do is if you don't want to actually just use an online model, if you want to use a model that someone else wrote, but you would like to run it on your own hardware, then you can download models from repositories like Hugging Face and TensorFlow Hub. These are the two big ones where people get a little bit, get their models from that are pre-trained. You can even, like, for example, Hugging Face offers sort of a spaces option where they basically give you a little container that you can run code in. So for example, you can experiment with the code first before you actually commit to it and download it and run it on your own hardware. On the right-hand side, that's sort of an attempt to use this QR code control. This is a random thing I found I was playing with. It's supposed to embed a QR code into an image that you have. It didn't work very well here. I tried the Storm Center logo and tried to get my short code URL QR code embedded here. I wasn't quite happy with it. But then, for example, now I could download the model, I could modify it, I could adjust it. That's all the things that these mods you can download allow you to do. A little word of warning, goes a little bit beyond the ethics here, but you're downloading Python code, you're executing Python code someone else wrote, so you have all of these supply chain issues here with it. Okay. So these models also come with their license. And I just used the QR code model here as an example, and that's the demo image they gave you. So I was more expecting something like this, which of course didn't happen. The license here is an OpenRail++ license. Now, what does that mean? Of course, just like we have many different open source licenses, we have many different licenses that govern the distribution of AI models. Here in this particular case, so they call it a responsible AI license. And this comes up when you hover over it. It gives you a brief summary of the license. I'm not sure if they used AI to create that summary. You can also look then at the full details when you click on read more. But it says here basically, yeah, you can use it freely. You can even redistribute it. They're just, again, some guardrails that the creator of the model put around to likely do something like inappropriate images and such to avoid that. So as long as you comply with that license, you may use it. In this case, probably not a big deal, not a big issue if you use a model like this with this license in your own sort of research, like if you find something to find anomalies in logs or some of the things that Dave talked about earlier, that would be an acceptable license if you try to use that. So in some cases, well, you may also want to create your own AI machine learning model or training model. There are a couple things that you sort of should consider here. First of all, sometimes you just don't need machine learning and AI. And that's, of course, a big thing these days. If you look at the startup scene, if you want funding, you better have AI somewhere in your business plan. And there's a lot of this AI washing, I have heard it referred to as happening, where people claim to do AI, but they don't really, or the AI is really just a front end for ChatGPT. And there's, again, nothing really special or different than they're doing other than basically create better prompts for you. So that's one thing to consider. Do I actually need AI to solve the problem? And then sometimes the reason also is the problem with using AI to solve a problem is that it usually or often does not help you understand the problem. And you can come up with a better, faster, simpler solution if you actually take the time to understand the problem that you're doing. And then, of course, once you're committed to actually using your own AI, well, where do you get training data from? And what's the quality of that training data that you're going to use? So yeah, some examples for things that I think don't require AI. Yeah, Word documents with macros. Once you understand how Word documents are formatted, how these docx files work and how to unzip them and how to parse them, then you may figure out that, hey, what I really need is more something like a regular expression than AI, or maybe even less than that. I just need a protocol parser to actually understand the Word document format, and then I can easily figure out that it contains a macro. And I look at all the stuff that Didier Stevens does and such with his Oli dump tools that do just that. They parse the document and then extract information that you want from it. Similar like PCAPs. Is it an IPv4 and IPv6 PCAP? Well, you look at the Ethernet type, you look at the IP header to figure out if it's that. You don't really need AI. Now, you may use a problem like this that's well understood, but you have an existing solution for it to experiment, to play with AI, with machine learning, just to figure out what if your code works. So that may be a use for a problem like this. But anyway, so if there's a simple signature, don't replace regular expressions with machine learning models. So if something simple works, and sometimes you don't even need a regular expression. I know regular expressions, of course, have their own problems. Here's like a little example, and that's one of my favorite information security research examples. About every 6 months, someone discovers that you're able to recover keystrokes by basically with audio tools. You basically just put a microphone next to the keyboard, have someone type, and then based on the different sounds different keys make, you're able to figure out, basically do a keystroke logger that way. This paper here was from 2005, and it already says that it's revisited. So there was work before that did keyboard acoustic emanations and recovered keystrokes from it. They say here they got a 96% recovery rate, whatever that means, of course. This was last year. Yeah. Someone did the same thing, but now with, well, more AI or deep learning here. So, basic machine learning is what they used here. And hey, look, they almost are as good as the paper 20 years ago. Yeah. 20 years ago was 96%, and now it's sort of a 95%. Now, they may have done some things a little bit different here, and they didn't use a language model, so it's independent of the language and such. But the problem there is solved, like I said, has been solved multiple times without deep learning. It actually probably has been solved at least a dozen times with different sort of deep learning approaches. That's because it's such a popular problem to solve. So first, make sure is the problem that I'm trying to solve here not already solved? And again, solved without machine learning. So why do I tell you not to use machine learning? Machine learning is cool in AI. Why should you not use machine learning? Well, there are a couple of reasons. Probably the number one issue here is the expense involved in training these models. It's basically a waste of resources. There's probably other things that you can do. If you look at the enormous amount of money, people, energy being sort of thrown at training AI models, like just recently, Microsoft in some discussion stated that one of the problems they're having is that their data centers run into limits as how much power a particular state can produce. That's why they're sort of splitting up their trust structure across different states. It's not necessarily for resiliency, well, part of it probably too, but it's also because just they can't get enough power in Washington state, so they have to put some of their systems into other states. And then the sort of more fundamental problem that using an AI model often obscures what's actually happening. You're probably better off understanding the physics, what's the nature of the problem. And AI models often don't do that. Like if you're using, for example, AI models to detect malware, often that's sort of seen as vastly superior to signatures. The AI model is really just a signature that you don't know how it works. It's still a form of a signature for the most part. And yeah, and then one reason why you may want to do it is just validate your coding skills, make sure the approach you're taking to coding a model is correct. And it can be good to have sort of some known solved problems for that, because that way you can verify your results and make sure that they're correct. Let me give you an example here. So this is just pull this from my home network, number of security alerts over time. And okay, I could probably find some kind of fast Fourier transform or so to match that. It would be a very simple approach, sort of one of the simplest kind of machine learning techniques here in order to figure out, well, is maybe this peak or this peak kind of an anomaly, something that I need to hunt down, or this dark blue peak down here. But just by overlaying a little bit of physics, basically, what actually happened. Here, these areas where you have more alerts, well, that's when I was home. The areas where I have less alerts, that where I was gone. Where this particular peak happened, well, that's when I was playing with the rules and doing some adjustments to it. So that already tells me way more about the nature of the data than any kind of fast Fourier transform would tell me, and some obscure like coefficients here that I have really no good understanding what they mean. So some of the problems that you kind of want to avoid also, and that's sort of where you get some more the other ethics issues. Do we really need better malware? Well, one thing that I often see, for example, is covert channels. Everybody is so excited about, hey, I found a new covert channel. Covert channels are covert until you know what to look for. So even if you have like DNS is something that sort of keeps coming up. That's of course, Dave just talked about that's an old thing and can be discovered. Can your model be abused? That's something, if you saw earlier this week, Microsoft came up with an amazing model to do basically deep fake videos. Only requires a headshot of the person and a minute of audio, and gets amazing quality deepfake videos. They're not going to publish the model. Now, of course, you may say, why did they create in the first place? There may be a reason behind this, just to inform the public, hey, if Microsoft can do it, others can probably do it as well. Yeah, and here, for example, all the existing models like ChatGPT wanted it to draw a picture of a robot, sort of backstabbing kind of, yeah? And no, it's not going to do it. It's not going to do it for me. Yeah, where do you get your training data from? Again, if you self-serve, if you created it yourself, how representative is the problem? If you get external data, who actually created it? Why did it create it? Because quite often the training data that you find sort of freely available was created for a particular purpose, and it may not match your use case. So one of the most dangerous things there is sort of bias in the training data. You're trying to train a general IDS. Well, the training that you download is only IPv4, has no IPv6 in it. Is this a problem? Well, that depends on the question that you're trying to answer with it. And definitely run your own quality control tests. Check that the problem space is sort of properly mapped with the training data. That's really what you're looking for, and that there are no sort of inherent biases in the training data before you. And then again, may I use it? Like some of these AI companies that basically spider the internet, not really concerned about whether or not they're actually allowed to use certain data to train their AI. So pretty much already covered that. The most important part here is make sure that you really cover the entire problem space here. That's really what the training data should be all about. And the good old information technology directive here, garbage in, garbage out, still applies. If your training data is bad, your model will be bad. So just a quick summary. We have about a minute left. But basically, as a researcher, AI does not remove your accountability. The researcher is responsible for the results and is also responsible for giving credit. Credit is not conserved. You can give credit, and that doesn't really take away from your effort to better understand the problem, to solve a new facet of the problem. So which tools did you use? Where did you get your data from? How did you use the data? How did you use the model? That can be your contribution. And then basically point out what's your contribution to the problem, and make sure that you just don't basically type the prompt for the paper into ChatGPT and then copy paste. That would be sort of the wrong way of using these AI models. Use them to augment your own contribution, make your own contribution better so you can actually focus on the actual problem. Anyway, that's all I have here. The slides should be downloadable after we are finished here. So if there are any questions, I'll keep monitoring a little bit the summit discussion channel here. And with that, I hand it back to Rob, I think.